Welcome to all. We will continue. Right now we are in cantilever beams with uniformly varying load. Last class we completed the questions when you never bother left side, right side. Intensity 0 at free end and maximum at fixed end, one question. Next one bookwork, one numerical. Then intensity 0 at fixed end and maximum at free end. Go through it. Now question number 17. Every time question I am dictating, because every time I don't have to write. Always remember, question will be dictated. Write the question. A cantilever beam is of length L. This I will not tell every time. In the question right now, I am not telling whether left side fixed or right side fixed. So you can take anything fixed. We will take fixed and left side, free and right side. Alternate solution will be there. Briefly I will tell. Now onwards, I will not write that much for alternate solution because some numbers are there. I'll just check it. It is for, oh, it's not there. Okay. Because question number 16 last time, all the 16 questions, once I solved with the left side fixed, then I solved with the right side fixed. So now onwards, I will tell usual. Okay. I will take left side fixed. So a cantilever beam is of length L. It is loaded by an uniformly varying load, see correctly, of intensity 0 at both ends. 0 at both ends and maximum of W per unit length at the center of the beam. That means uniformly varying load represented by an isosceles triangle. So span is L, exact center L by 2 maximum over. This statement I should not waste time. Load down, and now I will not tell. Reaction up, this will create clockwise moment. Reacting anti-clockwise moment. Okay. Take moment about A. Okay. Clockwise plus total load. Directly one step. Half into L into W is the total load. Multiplied by. Since it is uniformly varying load represented by an isosceles triangle, centroid will be exactly here. Remember, it is for the entire triangle. The resultant load will pass here. So directly into L by 2 minus ME equal to 0. MA will come WL square by 4. Sigma V0 upward positive VA minus the total load. Only load this time. Half into L in W equal to 0. VA will come plus WL by 2. Therefore, show the reactions. Now, what all I tell, you should write. Up to now, every time I used to write it here. Now, directly possible. See, what you do. This all over now, write the sketch once again. Don't write this values here. Put to, or refer here. You put this sketch directly. Total load down. Half into L into W. WL by 2. That much reaction up. Moment. Net moment and action. Half into, if you want somewhere right there, half into L into W, total load, multiplied by center is here, centroid, L by 2, L into L, L square, WL square by 4. Enter the answer. Okay, over. Then, if you are really serious, prepare one more question. Now, this is for your choice now. Fixed right hand. Put this way. Now, only change is reaction VB here. See, last time it was creating clockwise moment. So, reaction anti-clockwise. Now, we will create anti-clockwise about fixed end, clockwise. Calculation will be same. Same calculation. 16 times I have done it. Therefore, you complete it and close the question. Now onwards, I will not unnecessarily waste time writing same thing again and again. Okay, now. Question number 18. I will finish fast now because then I have to go to question number 19, important, 18. Question dictated. A cantilever beam is of length 4 meter, not 4, not 4, 6 meter. Okay, 6 meter. It is loaded by an uniformly varying load of intensity 0 at the ends, at both ends, and a maximum of 20 kilonewton per meter at center. So, if it is 6 meter, both of them will be 3 meter, 3 meter. Okay. Find reactions. Same sketch once again. Right here 3 meter, write 3 meter. Here you write 20 kilonewton per meter. Start. Take moment about A. Plus half into 6 into 20 is the total load. Half into 6 into 20 into exactly 3 meter. 3 minus MA equal to 0. Your MA will come. Calculator is not on. 180 kilonewton meter. 180 kilonewton meter. Let me check once again. Half into 6 into 20 into 3. 180, correct. 180 kilonewton meter. Sigma V0 upward positive plus VA minus half into 6 into 20 equal to 0. VA will come 120 plus 60 kilonewton. 60 kilonewton. Therefore, for the cantilever beam, if the intensity is 20 kilonewton per meter here, and length of beam if it is 6 meter, half is 3 meter, because important, they told maximum at center, the 3 meter required. This reaction is 60 kilonewton. This reacting moment is 180 kilonewton meter. Now, what all I told last time for the class for previous question, once again go back. If you remember, okay. Otherwise, just now I told something. Go back. Observe what I told and do it. And do it. Over. Now, question number 19. Remember, 19 and 20 are little concept oriented, important questions. I will put the question here, but I dictate the question. A cantilever beam is of length L. See, cantilever beam is of length L. Bookwork type L. Okay. It is loaded by an uniformly varying load which has intensity 0 at the ends. See, here also 0. And I told you, loaded by uniformly varying load. I write once again if you want. See, UVL with intensities 0 at the ends and maximum intensity of W per unit length at distance of A, some distance A from fixed end. Okay. That is 0, 0 here. See, somewhere here. I don't know. A can be more than L by 2 or less than L by 2. It does not matter. You randomly write somewhere here. Okay, one side. See. This way. It does not matter. That matters when you go for SFD BMD. W per unit length. I should check the camera. I'm going to upper side. See, distance A. This usually you remember, you try to B here. That B is not required now. You see later. This is A. Over. This is a question. A is fixed end. B is free end. Just for safety, checking the camera once. Okay, no problem. Correct, perfect. Okay, now see correctly how to solve. Okay, now see. It does not matter whether A more than B or B more than A, W per unit length. Unit length. See, this way. It is not center, it is unsymmetrical. So this is A. You do one thing, make this point, this is B, let this point be C. Okay, 1 minute. Make this point C. Now, from here to here is A, span is L. Over. This is a question. Okay, start. Sigma m, as usual, I will take left side fixed. I will tell something there later. Okay. This is your choice. Sigma m about A0, take clockwise positive. See now, correctly observe. Go back to type of loads and go through what all I told. For a triangle in general, I told if distance from here is A, at that time I told if this is B, here B is not there. If you want this distance, you take L minus A. There is no B given. Then I told total load is simple. How? Area of the full triangle, half into L into W. But where it is acting, I told if you take the full triangle, it will act slightly, it will act that side where distance is more. Here, this distance looks like a little more than this distance, so here. But remember, whether it is what? Whether it is coming here or here, this distance formula is same. Now make a slight note here, see, slight note. If you want this distance, light line, make a note here. This is a total load. I told from here, it is L plus A divided by 3. If you want from here, it will be L plus this distance divided by 3. I already explained it many times. Go through it. Okay, start. Now, first, sigma m about A0. Moment of this load. Half into full load. Half into L into W. That is full load. See, I am considering entire loading. Make a note here. I am considering entire loading into, from here to centroid is L plus A by 3 minus MA equal to 0. Therefore, your MA will come, see, 1 minute now, see, WL by 2 and 3, 6. It will come WL by 6 into L plus A. Oh, I should write red color answer. WL 3 into 2 is 6. It will come plus actually because goes that side, plus into L plus A will come. Okay. Then sigma V equal to 0. Upward positive. You get plus VA minus the total load is half into L into W full load equal to 0. Therefore, VA will come plus WL by 2. Therefore, for a cantilever beam, if no 6 meter, if there's a cantilever beam is here, I am taking fixed at left end. If this type of beam, if the uniformly varying load goes this way, W per unit length, and then again decreases to 0 here. If this type of loading is given, suppose this distance is A, total length is L, this vertical reaction AB, okay, B is not required, this vertical reaction VA equal to WL by 2, this reacting moment MA equal to WL by 6 into L plus A is the answer. Okay, now, other thing you write, interchange, put the support here, see, interchange. If you want, you can solve one more question this way. But remember now you should take, see, this should be A now, because I have not told A from left and right hand. So once again, same answer will come. Direct also you can try now. Okay, this is all class over now. Okay, now make a note. Okay, everything is over. Make a note. This formula, L plus A by 3, you have to remember. I told sometimes people have difficulty. See, for right angle triangle, 1/3, 2/3 they remember. But when it comes to which one? That trapezium formula or that general triangle formula, people get little confusion. Such people, you write, what they can do is right here. Those people who do not remember this formula, see what they can do. Let me see what happens now. See, put the beam once again. Once again, draw the beam. Little work is there now. Okay. This way and this way. This is W per unit length. Unit length. This reaction is A point. A, this is B. You take this as C. This reaction is VA. This reaction is MA. MA. From here to here is A. This full length is L. Space problem. Okay. Full length is L. I write L here. Then do one thing. You consider, see, this triangle and this triangle separately. Then you require this distance. In the question, if B given, you can take B. Or you do one thing. If it is A, this is L minus A. Okay, write it, L minus A. Now do one thing. See, for right here, this triangle, resultant load will be here. For this triangle, it will be somewhere here. This load equal to half into A into W. This load is half into L minus A into W. This distance is 2/3 of A. This distance is 1/3 of L minus A. First of all, I should not tell all these things. Okay, start now. Sigma M about A0, take clockwise positive. Start. Clockwise positive. Half into A, little length it will become now, into W. Into W is the load, multiplied by moment about A. This is 2/3 of A. Then plus once again, half into L minus A into W is one more load multiplied by this is A plus this is moment about this point. This is A plus another 1/3 of L minus A, then minus MA equal to 0 is the equation. Then, therefore, right here, therefore, your MA equal to, see, this minus will become positive that side. See, you got directly answer with one single step here. What? Half into L into W into L plus A by 3. Single step you got it. Now, you have to expand it. MA equal to, see, minus plus. Half AW, half L minus A in W. So, half W will be outside. So, W by 2, see here, W by 2 and W by 2 into A into 2/3 of A is, A into 2/3 of A is 2A square by 3. That is this term. See here, W by 2, I am taking outside. Even half, this half also gone outside. W by 2, 2 by 3A into A is 2 by 3A square. Plus here, see here, half into W over. Plus this is L minus A, little unnecessary becoming complication. See, L minus A into bracket A plus L by 3. You take 3 common denominator here. If I take 3 common denominator here, it is 3A plus L minus A. See, W by 2 outside. 2 by 3a into a, 2 by 3a square. Then half w outside, L minus a into 3 common denominator, 3a plus L minus a, or now this 3 and 2 will become outside, it will become 6. W by 6, see finally you got W by 6. L will come later. W by 6 into 2a square plus L minus a into L plus 3a minus a is L plus 2a, correct, L plus 2a. L minus a into L, 3a minus a is a by a over. Still you have to go there, see, you have to reach there, or equal to, where I'll write here now, space problem, okay, equal to, see here, W by 6 times 2a square plus L into L square, L into 2a minus 2al, a into L minus al, 2a square plus L into L is L square, L into a is plus 2al minus al minus 2a square. Okay, now 2a square will cancel. This will become W by 6 times L square plus 2al minus al, or now it will become W by 6 times, see, L square plus 2a into L into, okay, 2L into a, 2L, one L into 2a minus a equal to W by 6 into L square, 2a minus a is a plus al, L square plus al, or equal to, you can take L outside, WL by 6 into L plus a. Oh, right, oh. Same answer came. It has to come. Otherwise, mathematics has no meaning. See, I'll tell frankly with you, I never practiced this one. I just started. I wrote in front of you. See, if I want to escape, I should have paused the recording, silently write everything, then come back, start the recording and explain to you. No, I got confidence. Answer has to come. Otherwise, there is no meaning for structural engineering. So finally, WL by 6 into L plus A came. Oh, now, next, one more. I remove the sketch now. Okay, this is over now. Next, sigma V0. Sigma V0, see, upward positive. Now, plus VA minus total load. People for taking moment, they will divide into two triangles. But when you want total load, we want only area. If you divide into two parts, somebody will laugh. They will tell, why can't you take the full area? No, centroid problem. Centroid problem you already considered by dividing. Now only area is there. Why you want to divide? Oh, correct. Okay, leave it. Then directly write here, what? Don't divide. Directly write minus half into L into W equal to 0. You will get WL by 2. Okay, or, no problem. Minus, okay, half into A into W minus half into L minus A into W equal to 0, or your VA equal to See that side, half into A into W, minus becomes plus that side, plus half into L minus A into W, or W by 2 into A plus L minus A cancels, WL by 2. Okay, that also will do. But no, for taking moment you will have problem. I know, because remembering that L plus A by 3, so many people does not know it. They will divide. But when you want only area, for sigma V0, distance is not required, only area, then take half into L into W, over. Okay, this question over. Same way, see, if you want try other way, tell what you have to do. Try it. I think I already told it. I already told it now. This way you should write. See, from fixed end A, other side B, you should try this way. Okay, now I will solve one more question where I will not give in terms of A. I will give a part of L. Actually easier. See here, A and L has no link. Now I will give a link, numerical last question. So I will give this distance as a part of A, so that then perfectly there is no AL will come. Easily you get the answer. Then I will wind up the class by taking one numerical question. See, now what I will do is, I will take this distance little more. And one more thing I will do. This time I will start the question by taking fixed end that side. Okay, that I will prepare. Prepare means not preparing for solving, preparing to record it. I never prepared to take a class. Next question number 20. I am dictating, but you should see correctly what I am telling. See, you should write the question. A cantilever beam of length L, this time I am telling you, is fixed at the right end. First time in the class I am telling fixed at the right end. Now, next. It is loaded by an uniformly varying load which has zero intensity at both the ends and maximum intensity of W per unit length at a distance of L by 3 from free end, or from, now I can tell, not free end, I can tell from left end also. Okay, you write from left end, over. Find reactions. Okay, start as usual. Let VB and MB, I will not explain why clockwise etc. be moment at B. Take moment about B. Now, those people who can afford, they can do one thing, they can take complete triangle. Then total load will fall somewhere here. See, the total load equal to half into L into W is the total load multiplied by centroid of the entire triangle. See, from here I want distance from B. So if it is L by 3, you require this distance, calculate, it is 2L by 3. You require this distance. Then, see, this distance will be equal to, formula is full length L plus this cut length 2L by 3 whole divided by 3. So, into L plus 2L by 3 equal to 0. Now calculate. 1 minute. How to calculate? See here. W into L. Here L comes outside. WL square guaranteed. This minus becomes plus that side. Now, how to get the number? See, WL square. See, how to get the number is very simple. You are engineers. See, what I will do? Half into 1 by 3 into bracket 1 plus 2 by 3 equal to 5 by 18. So 5 by 18 WL square is the MA, sigma V0 plus VB minus half into L into W0, VA will come. So this is the reactions. Enter the answer. Okay. Now, those who want, solve one more question. But this time you write, same question you write here. See, a cantilever beam of length L. Sorry, this time that's already. Now do one thing. A cantilever beam of length L, right, is fixed at the left end. It is loaded by uniformly varying load of intensities 0 at the ends W and maximum of W at L by 3 from free end. So now everything will come same as this one. This VB will come VA, but MB will come MA anti-clockwise here. You solve it. Now I should not solve. It will be insult if I solve now. So copying this one you can solve. Now make a note. People who find difficulty for this formula solve. Okay, no problem. For them, see, write a note for them. For those who do not remember those formula, etc., what you do is, this is one triangle. Take a triangle here. This is another triangle. This total load is acting here. This is from here 1/3. That 1/3 is not this 1/3. This is given 1/3. That is standard 1/3. They can give instead of L by 3, L by 4 also. They can give L by 5 also. This will become 4L by 5 then. Do not remember this L by 3, 2L by 3 is that 1/3, 2/3. So this is 1/3 here. Total load is acting here. From here will be 2/3. Remember that one. Okay, start. Sigma m about B0, take clockwise positive. Take this load minus half into L by 3 into W is this total load multiplied by moment about this point 2L by 3 plus 1 by 3 of L by 3. 1 by 3 of L by 3. Okay. It's a bracket here. Okay. Then again minus moment of this load. Half into 2L by 3 into W is one more load into 2 by 3. See, from here to here is 2 by 3 of 2L by 3. 2/3 of 2L by 3 not equal to 0 plus MB equal to 0. Therefore, you get the value of MB. My guarantee, it will come plus 5 by 18 WL square and sigma V0 you only write plus VB minus this load. Even if you do that way also, it will come WL by 2 work out. Now, I will give a trick for you. Some people will tell, they will waste 5 minutes to simplify this one. No, use capacity engineers. See, what to do is first decide MB minus, that side become plus, guaranteed. Then WL, L outside. So WL square guaranteed. Now only number required. See, both of them, that side is positive. See how to operate calculator? Half into 1 by 3 into bracket 2 by 3. This part is rubbed out there. It's 2L by 3. Okay. 2 by 3 plus 1 by 3 of 1 by 3. One number over. Then again plus half into 2 by 3 into 2 by 3 of 2 by 3 equal to 5 by 18. I cannot show my calculator. I have to bring very near to the camera. Okay, 5 by 18 WL square. Okay, work out this question. Now I am going to last question of today's class, question number 21, where I will go for a numerical. I will do one thing. Instead of wasting time on left side fixed, right side fixed, left side fixed, I will solve a question here. Right side fixed, different numerical I will give for you. You solve. I will give with the answer. So I will give with the answer and briefly I will explain there. Okay. Start. I will first numerical part. I will write the. this class, today's class, last question, 21. I think I changed the question number. I don't remember. By chance, 21 was previous question. You change it. In the title I will write. Or question number, adjust it. Suppose I forgot to change the question number, you put next question. Later when I go for next class, I will check the video or recording and go to correct number. Dictated. Cantilever beam of length 4 meter, I am telling now, is fixed at left end. This time I am telling fixed at left end. Subjected to uniformly varying load with zero intensity at both ends and maximum of 60 kilonewton per meter at 1.2 meter from free end. Or right end also I can tell now. Over. Find reactions. Usual statement. This I should not waste time now. AB. A is fixed and be careful. VA, etc. Take moment about A. See, direct solution. Plus complete triangle. If you take resultant load will be. See, you make a note here. If you take the complete triangle, resultant will be somewhere here. How much? Total load? Half into 4 into 60 into from here to here will be. This is the centroid for the entire triangle from A to B. Total length is 4. This cut length is 2.8. See, when this is 1.2, this is 2.8 divided by 3. Minus MA0, get MA. Sigma V0, get VA. Then enter the answer. Now, those who find difficulty for this one, you draw one more. See, now this sketch you should draw something like this. See? One right angle triangle here, one more right angle triangle. For them, not this way, right this way. See, half into 2.8 into 60 into from here to centroid. 2/3 of 2.8. First of all, every class I can't tell this one. See, here and here. Plus once again, half into 1.2 into 60 into 2.8 plus 1/3 of 1.2. 2.8. Oh, I think I start from that side. Okay, interchange. Okay, start once again. Half into 1.2 into 60 into 2.8 plus 1/3 of 1.2. Here, half into 2.8 into 60 into 2/3 of 2.8 minus MA0. MA will come. You calculate. I will calculate with the calculator still switched off. 272 kilonewton meter. It has. I got confidence. 272 kilonewton meter. Right here. Now, those who want, now I will do one thing. Left side fixed, right side free. Add any numerical. I will give one question for you to solve. You solve it. I will change a numerical. This is left side fixed, right side free. Now I will change over to right side fixed, left side free. I want a statement all. I will briefly explain. You solve it. Okay, done. Question 22. Dictated. A cantilever beam. Oh, sorry. Well, right, I want right side fixed. See, I forgot it. A cantilever beam is of length. Any length will do. It's of length 3 meter. It is fixed at right end. A, B. It is loaded by an uniformly varying load which has intensity of 0 at both ends and maximum of some intensity 30 kilonewton per meter at a distance of 1.6 meter from free end, left end. If that is 1.6, it can't be 1.6 because 3 has 1.5. 1.2 meter from free end. So if it is 1.2, this will become 1.8 meter. Remember, not given, calculated. Okay, solve the question. Vertical reaction BB. You first write the question, write step by step, consider the reaction solve. I will tell you, take moment about B. Minus half into 3 into 30 into directly CG here, centroid here, 3 plus 1.8 divided by 3 plus MA equal to 0, you get the value of MA. Sigma V0, you get the value of VB. Or those who find difficulty, what do? Half into 1.2 into 30 into 1.8 plus 1/3 of 1.2 and then half into 1.8 into 30 into 2/3 of 1.8. Whatever you want, you can do it. I'll give the answer for you. 30 into 1.5. Calculate this time calculator should be on because why? I am calculating 30 into 1.5. 45 kilonewton. 45 kilonewton. 3 plus 1.8 divided by 3 into 45. 72 kilonewton meter. Yet I check the answer. 1.8 into 3 into 2 by 3 of 1.8 into 1.2 into 30 into bracket 1.8 plus 1.2 divided by 3. 72. I am checking by part also. Okay, not required. Solve the question. Question 22 over. Now, next class will be question number 23. If this numbering is correct. By chance, if any numbers are wrong, I will check the recording and next time I will tell correct number. I will tell previous class in the order, change the numbers. Now I lastly go for uniformly varying load represented by a trapezium, this type. Bookwork, numerical, both will be there. Okay, that is in the next class. Okay, thank you. Work out all the questions and gain as much as possible knowledge.